Hi, this is Nick Bassini and we're watching Nick SPN. Today we are going to see some weightlifting with some scientific explanations, mainly on the Newton's 3 laws of motion. And first thing I want to talk about is Newton's first law of motion, which says that an object not moving, an object stopped, it's going to still stay stopped. It's not going to move unless a force acts upon it. And that's pretty much what happens on weightlifting. I mean, that's obvious. Show you all. The bar's not moving, and still it's not gonna move unless the perfect athlete called Nick Bassini act with his force upon it. Okay, now it's moving because I'm applying my force over it. Otherwise, it wouldn't be moving. Because nothing moves unless a force acts upon it. And if it's moving, it's gonna keep moving unless a force acts upon it as well. In this case, the force that makes it stop and makes the weight go down, it's called gravity. Because when I'm pushing it up, if this that I'm doing right now happened on the space, as I push the bar up, it would keep going to the skies. It wouldn't stop. But we're under gravity's effect. So gravity is pushing the weight down. So that's pretty much why it doesn't just go as I push it. So Newton's first law of motion, that's it. It's not gonna move unless I apply my force to move it, and it's not gonna keep going because gravity is pushing it down. And Newton's second law of motion says that the acceleration, the movement I'm gonna cause upon this object that I want to move depends on the force that I'm gonna apply it, and it depends on the mass of the object I want to move. So, which means that, I mean, probably a 6-year-old kid wouldn't be able to lift this because it's too heavy for him. He doesn't have strong enough. He's not strong enough. He doesn't have force enough to lift those. So that's all how it works. It depends on the force that you can apply over this object. If I don't apply force enough, let me just not push. If I don't put a good amount of force into it, it's not gonna move. At least not as I want. If I just try to do it with my fingers, not moving at all. It's not gonna move. Okay, that's pretty much it. And Newton's third law of motion, it says that for every reaction, we have an opposite reaction of same amount of force. And here is very obvious. I mean, let's look at it. I'm pushing the bar, okay? And Newton's third law of motion is what pushing me down. As I'm pushing the bar up, the bar's also pushing me down. Y'all just can't see, but I actually here can feel it because the bar is pushing me down. I have to keep a force in my whole body so that I don't fall or whatever. Because as I push it up, it's pushing me down too. So that's pretty much Newton's first, second, third law of motion. Now I want to talk about a little bit about kinetic energy, total energy, and potential energy. Potential energy we got here on weightlifting, in this case benching, when the bar is at its highest point, as we're gonna see right now. Right now, I got my most gravitational potential energy I can have benching this bar. Because you see, if it falls, it makes kinetic energy. It makes energy. Okay? It's changing energy. Okay? Here, it doesn't have as much potential energy as it has here. Okay? And kinetic energy, we can pretty much say it's just the energy of the movement, which the incredible athlete Nick Bassini is going to show you all right now. kinetic energy, it's nothing but, as I said, the energy of the movement. Something that it's moving. So right now, it's moving. It's gonna keep moving. That's kinetic energy. It's potential energy being transformed into kinetic energy. Okay? And the other kind of energy I want to talk about, well, we covered potential, we covered kinetic, and we gotta talk about this total this total energy. I mean, this whole process, the energy wasn't made, it wasn't created, as well as it wasn't destroyed or just disappeared. The energy just changed from right here, it changed to potential energy to kinetic energy. As it goes down, here it's potential. As it's going down, it's kinetic energy, okay? And this is something, it's kind of a law of the energy that says that energy cannot be created or made or destroyed or just disappear. It just can be changed in different kinds of energy. In this case, I have three kinds of energy being used here. I have potential energy right here, and then I have kinetic energy that was created by the potential energy. And the bar would keep falling down until my elastic energy of my body push it up again, creating kinetic energy. So potential energy, kinetic energy, elastic energy. Okay? So what I mean by all of that is that neither of those energies that I just showed you guys was created. They just changed from one to another. Potential changed it to kinetic, kinetic changed it to elastic, elastic changed it to kinetic. And that's pretty much how energy works for everything. Another thing I want to talk about is friction. The friction, I'm talking about gloves. Without these gloves made out of leather, don't know if you guys can see well, but they're made out of leather. And without this, I'll tell you, it would be really, really harder for me to lift anything without those, because those really make me be sure that no matter what, unless my arm stop making force or something, the bar's not gonna just fall. Why? Why they do that? Because the leather or the gloves have a way more friction than only my hand. If only my hand is touching the bar, then I have a way less friction than if I had the gloves on. Then I don't have to squeeze it more, because the gloves, they kind of grab the bar better than my hands do. They kind of grab the bar by themselves because they have more friction. So here, it's really tougher. It's really harder because I have to squeeze the bar more, because I know that otherwise it can fall down or whatever, because the friction that my hand causes over the bar, it's almost nothing compared to the friction that the gloves cause over the bar. And I think that's pretty much it. It was good to see you guys tonight. See y'all next night. Miss Long, love you. Thanks to all my fans. See you on NFL next year. Bye.